Question is, in figure below, if I equals to cos 40 and V equals to sin 40, the element is, see, I is cos 40, which we can write in this way, that is sin of 40 plus 90 degrees. Here V is sin 40, means what? The angle between V and I is, means current leads the voltage by 90 degrees. Hence, element must be a capacitor, then only current, because see, I is nothing but V by 1 by j omega c. That is V j omega c. Means I is V omega c at an angle of 90 degrees. So the element must be a capacitor, which is option B is correct. The question is, if CD and CS represents the depletion and diffusion capacitances of a diode respectively, which one of the following statement is not correct? So from the diode concepts, we know that the diffusion capacitance CS is nothing but tau I by eta Vt, and the depletion capacitance is epsilon A by depletion width W. Means here CD, that is depletion capacitance, varies inversely with the depletion width. So from the depletion capacitance definition, it is true. And comes to statement B, CS varies directly with the rate of change of diode current with respect to diode voltage, because this is dq by dV is, it is nothing but dq is nothing but proportional to di, hence CS is directly with the rate of change of current with respect to diode voltage. Hence second statement is also correct statement. Comes to statement D, effective junction capacitance is the parallel combination of CS and CD, because those both comes in series, so the effective capacitance is going to be a parallel combination. Comes to statement C, CD varies directly with the transit time. See, the depletion capacitance doesn't depend upon the transit time of the carriers, hence the wrong statement is C, hence option C is correct. Here the question is, a BJT Darlington pair has. See, before getting into the option, we must know what a Darlington pair is. See, here the Darlington pair configuration is represented like this. Here, suppose this current is IB, this current is 1 plus beta IB. If both are having current gain of beta, then this is going to be 1 plus beta square IB. We know that this input impedance is HIE plus 1 plus beta into RE. Again, this input impedance is going to be HIE plus 1 plus beta. This input impedance is RN. Hence, the Darlington pair, what it will do is, it will give the high input impedance as well as the high current gain, because the output current is 1 plus beta square times of the IB. Hence, option A is correct. Question is, in circuits fabricated by Enter process for electrical isolation between N MOSFET and P MOSFET in the ICs. See, this is an Enter process, means first of all we have to take a P substrate, we have to construct an N well. Okay, this is nothing but N substrate. By using this one, we are going to construct a P type of MOSFET. By using a P substrate, we are going to construct an N MOSFET. Means what? There should not be any charge exchange between here to here or here to here. So for that one, what we will do is, the P substrate must be connected to the, because here in this consists of source and drain. Here is also source and drain. Similarly, there should not be any transfer, because this is N type, this is P type. There should not be any charge transfer between these two things. So the P substrate must be connected to the most negative potential available in the circuit, as well as the N substrate must be connected to the most positive supply available in the circuit. Hence, according to these options, option D is correct. Here the question is, the transfer function is given as h of s. So we have to match the least between the least one and the least two. Okay. So suppose if k1 and k3, that is, if we check the condition k1 k3 k1 k3 equals to 0, then h of s is going to be what? K1 k3 0 means it is going to be k2s s square plus s omega naught by 2s, this is omega naught square. Now substitute s equals to 0. S equals to 0 means h of s is going to be k2s omega naught square. So it is going to be a 0. S infinite means h of s is going to be k2s and s square. So it is also going to be 0. Means what? The condition, that is k1 k3, if k1 and k3 equals to 0, h of s acts as a band pass filter. Hence P is 4. Now if we check the condition Q, k1 k2 equals to 0 means h of s is going to be k3 s square plus s omega naught by 2 plus omega naught square. So if s equals to 0, h of s is going to be k3 by omega naught square. S is infinite, h of s is going to be k3 by s square, which is 0. Means for low frequencies it is a constant, for high frequencies it is 0. Means it is a low pass filter. That is, now if we check R, it is Q is 3. Similarly, if we use these conditions k2 k3 equals to 0, h of s is going to be k1 s square omega naught by 2s plus omega naught square. At s equals to 0, h of s is going to be 0. At s is infinite, h of s is going to be a constant, which is k1. So if we check these conditions, R acts as a high pass filter, hence R is 1. So remaining as it is acts as a band reject filter. So P is band pass filter, Q is low pass filter, R is high pass filter, and S is, S condition gives band reject filter. Okay, that is P, Q, R, S.